Good morning and welcome to another edition of Auto Intelligence, your perfect companion to your Tuesday breakfast ritual as we bring you the latest insights from the ever-evolving automotive landscape. I'm Steve, alongside my co-host Claire, and we're part of the Auto Agentic team bringing you perspectives that cut through the noise and deliver real value.
That's right, Steve. It's Tuesday, May 6th, 2025, and today we're exploring a technological revolution that's happening right now. The robotic revolution, how AI and automation are transforming the automotive industry. From assembly lines deploying humanoid workers to showrooms powered by predictive analytics, the industry is undergoing its most significant transformation since Henry Ford's assembly line.
The numbers are truly staggering, Claire. According to Fortune Business Insights, the global automotive robotics market reached $11.21 billion this year and is projected to more than double to $26.76 billion by 2032, representing a compound annual growth rate of 13.2%. That investment reflects how central these technologies have become to automotive competitiveness.
And it's not just robotics. The automotive AI market has expanded dramatically too. Research Nesta estimates the market has reached $5.05 billion this year, while Grandview Research projects $5.22 billion. These investments are flowing across the entire value chain, from design and manufacturing through to sales and after-service support.
When we look at the regional breakdown of this investment, it's fascinating to see how geographic priorities are shaping adoption. North America's automotive AI market is projected to reach $1.41 billion this year, growing at 28.58% annually. But it's Asia-Pacific that dominates with 29.39% market share, driven largely by China's Made in China 2025 Smart Vehicle Initiative.
European manufacturers aren't falling behind either. The EU's Green Deal and ambitious carbon neutrality targets are pushing manufacturers to adopt more efficient production methods. Already, 22% of new EU vehicles ship with AI-powered driver monitoring systems, a figure expected to double by 2027.
Today, we'll examine this transformation, the state-of-the-art technologies being deployed, the companies leading innovation, and how these advances are reshaping both manufacturing and the customer experience. Let's start with what's happening on the factory floor.
The automotive manufacturing sector continues to lead global industries in automation adoption rate, with the International Federation of Robotics reporting a remarkable milestone this January. Over 4 million industrial robots are now operational in factories worldwide.
What's particularly interesting is the acceleration we're seeing. The IFR's 2025 report reveals the global market value of industrial robot installations has reached a staggering $16.5 billion, with robot density in factories more than doubling compared to just 7 years ago.
That density increase is particularly pronounced in automotive manufacturing. While South Korea leads overall with 1,000 robots per 10,000 employees, we're seeing China emerge as a manufacturing powerhouse with 470 robots per 10,000 employees, placing it third globally. The United States has reached 295 robots per 10,000 employees, continuing its steady automation growth.
The impacts of this automation extend far beyond simple productivity gains. McKinsey's latest analysis shows that AI and robotics have collectively reduced production time in automotive plants by 17 to 23%, while improving safety metrics by reducing workplace incidents by up to 35%. Manufacturers are finding that properly implemented systems not only work faster, but also create safer environments for their human colleagues.
Marina Bill, president of the International Federation of Robotics, emphasized this growth in her keynote at the Global Automation Summit last month, stating, "We've entered a new era where AI-powered robotics is revolutionizing manufacturing. The synergy between physical robots and artificial intelligence creates systems that optimize through experience rather than pre-programming, fundamentally changing what's possible in production environments."
This synergy between AI and robotics has significant implications for sustainability as well. GM has deployed AI-powered systems to analyze energy consumption patterns in its factories, dynamically adjusting operations to minimize waste. This approach has reduced energy use by 15% at select facilities this year while maintaining production output. Given rising energy costs and environmental regulations, these efficiency gains translate directly to bottom-line improvements.
One of the most impactful applications of these technologies is predictive maintenance, using advanced analytics to anticipate equipment failures before they occur. These systems now integrate with Internet of Things sensors throughout factories, creating a connected ecosystem that dramatically reduces downtime.
The results speak for themselves. A comprehensive analysis by IBM's Manufacturing Intelligence Division found that automotive manufacturers implementing AI-driven predictive maintenance have reduced unplanned downtime by up to 50% and extended the operational life of critical equipment by 20 to 40%. When you consider that a single hour of unplanned downtime can cost an automotive plant between 1.3 and 2.1 million, the financial impact of these technologies becomes clear.
Robert Chang, Global Director of Manufacturing Technology at Ford, recently shared that their implementation of AI maintenance systems has transformed their approach to production reliability. At the Detroit Manufacturing Technology Summit in February, he noted, "Our AI systems now routinely prevent catastrophic failures that would have previously resulted in days of lost production." The system identified a potential drive system failure at our Louisville plant last month that would have impacted 2,500 vehicles had it occurred. That single prevention paid for our entire predictive maintenance program.
Ford's experience reflects a broader trend across the industry. The average automotive manufacturer is now preventing 12 to 15 significant equipment failures annually through AI-driven maintenance, according to recent industry analysis. These systems essentially pay for themselves within the first year of operation, making them one of the most cost-effective technology investments available to manufacturers today.
Beyond maintenance, quality control has been revolutionized by computer vision and machine learning. These systems can now detect microscopic defects that even skilled inspectors might miss, analyzing thousands of components per hour with consistent accuracy. A McKinsey analysis last quarter found that automotive manufacturers using AI-powered inspection systems have reduced defect escape rates by up to 80% compared to traditional methods.
These quality improvements translate directly to customer satisfaction and warranty costs. According to J.D. Power's latest vehicle dependability study, manufacturers with the most advanced AI-powered quality control systems scored, on average, 31% higher in initial quality and 27% higher in long-term dependability. When you consider that warranty costs can consume up to 3% of an automaker's revenue, these improvements represent substantial financial benefits.
These quality improvements go hand in hand with another breakthrough technology, digital twins. These virtual replicas of physical production systems enable engineers to simulate and optimize processes before implementation, dramatically reducing development time and costs.
Siemens' 2025 Digital Enterprise Report highlights that automotive manufacturers using digital twin technology have reported development time reductions of up to 30% and productivity improvements of 15 to 25%. These gains are particularly significant in electric vehicle production, where manufacturing methods continue to evolve rapidly.
The concept of digital twins extends beyond individual machines to entire production lines and even factories. BMW's next-gen production system, implemented at their Debrecen plant in Hungary, creates a complete virtual replica of the facility that updates in real time. This allows engineers to simulate changes to any aspect of production and immediately see the impacts throughout the system.
Dr. Milan Nedeljković, BMW's board member for production, explained the significance of this approach at their innovation showcase last quarter. Our digital twin technology represents a fundamental shift in how we approach manufacturing. Every physical element in the plant, from the smallest sensor to the largest press, exists simultaneously in the virtual environment. This allows us to optimize continuously, running thousands of simulations to find the most efficient configurations without disrupting actual production.
Thomas Müller, Volkswagen Group's Executive VP for Automated Driving, elaborated on their digital twin implementation at the European Manufacturing Forum in March. Our Zwickau plant's digital twin enabled us to increase production capacity for our ID family of electric vehicles by 23% without adding physical space. We simulated over 300 potential configurations virtually before implementing the optimal solution, saving months of trial and error on the actual production line.
These virtual environments also serve as training grounds for the AI systems that control increasingly automated production lines. By running simulations thousands of times faster than real-time, manufacturers can rapidly train machine learning models to handle everything from normal operations to rare edge cases and potential failures.
This simulation-based training is particularly valuable as manufacturers implement more sophisticated robotic systems. Traditional industrial robots excel at repetitive tasks in controlled environments, but they struggle with variability and require extensive reprogramming for new tasks. The latest generation of AI-enhanced robots is dramatically more flexible, learning from human demonstrations and adapting to changing conditions.
While digital twins represent a significant advancement in planning and optimization, perhaps the most visually striking development has been the emergence of humanoid robots capable of performing complex tasks previously reserved for human workers. This is no longer science fiction, it's happening right now on production floors.
BMW has been at the forefront of this trend, partnering with Figure AI to deploy their Figure 02 robots at BMW's Spartanburg, South Carolina plant. As of March 2025, these robots are performing specific body shop tasks, retrieving metal sheet parts from logistics containers and placing components onto welding fixtures.
The Figure 02 robots represent a significant departure from traditional industrial robots. Rather than being programmed for specific movements, they use advanced computer vision and AI to understand and interact with their environment. This allows them to handle variations in part positioning and adapt to unexpected situations without human intervention.
What makes these robots particularly remarkable is their ability to learn from demonstrations. Rather than requiring complex programming, factory workers can simply show the robot how to perform a task, and the system's AI translates that demonstration into a generalized understanding of the objective. This dramatically reduces the time required to deploy robots for new tasks.
Milan Nedeljković, BMW's production board member, offered insights into their approach during the company's Q1 earnings call. We are exploring humanoid robot applications through early testing, aiming to industrialize this technology from development stages. While we're taking a measured approach, we see significant potential for these systems to handle tasks that were previously difficult to automate.
Carolyn Richter, BMW's head of next-generation robotics, elaborated on the specific capabilities they're focusing on. While bipedal locomotion isn't essential for many applications, upper body dexterity, particularly arm and hand functions, shows tremendous potential for production tasks. The Figure robot's ability to understand spoken instructions and adapt to changing conditions represents a significant advancement over traditional automation.
The Figure 02 robots at BMW's Spartanburg plant use a system called Helix AI for environmental perception and spoken instruction comprehension. This allows plant supervisors to provide verbal guidance and feedback, with the robots adapting their behavior accordingly. One particularly impressive aspect is the robot's ability to ask clarifying questions when faced with ambiguous instructions, much as a human worker would do.
BMW's approach to humanoid robotics highlights a broader trend in the industry, the focus on collaborative systems that work alongside humans rather than replacing them entirely. The ideal scenario combines human creativity, judgment, and adaptability with robotic precision, consistency, and endurance.
Tesla is also making significant strides with their Optimus humanoid robot program. While they haven't yet reached the mass deployment they initially projected, industry analysts expect greater deployment in the coming 18 months. These systems are designed to handle repetitive or hazardous tasks in manufacturing environments, potentially transforming production economics.
During Tesla's most recent earnings call, Elon Musk provided an update on the Optimus program. We're seeing encouraging progress with Optimus. The latest generation has significantly improved dexterity and load-carrying capacity. We've successfully integrated several units into our Fremont facility for pilot operations, and the early results on task completion and reliability are promising.
Research firm Third Bridge identifies this year, 2025, as the inflection point for humanoid robot scalability across the automotive industry. Their forecast suggests over 45% of automotive manufacturing tasks, including welding, inspection, and parts handling, could be automated using these systems by next year.
The economics of these systems are compelling. While the initial investment in humanoid robots remains high, currently between $125,000 and $250,000 per unit depending on capabilities, manufacturers are reporting payback periods of 20 to 30 months for applications with high utilization. As production scales and technology matures, these costs are expected to decline significantly over the next 3 years.
Looking beyond traditional manufacturing tasks, AI and robotics are also transforming automotive manufacturing's sustainability footprint. Modular vehicle design powered by AI allows manufacturers like GM to reconfigure assembly lines for multiple models, reducing material waste by up to 25%.
Energy optimization is another area seeing dramatic improvements. AI-powered systems are enabling smart energy management solutions that slash operational costs by 20 to 30% for early adopters, according to Industrial Automation's 2025 Sustainability Report.
Even more impressive are the advances in circular economy practices. Material recovery algorithms improve the identification and sorting of recyclable battery components, aiming for 95% recovery rates by 2026. Supply chain optimization tools track material flows to prioritize reused components, reducing mining demand for critical minerals like lithium. These technologies are crucial for addressing one of the electric vehicle industry's most significant environmental challenges.
You're listening to Auto Intelligence, sponsored by AutoAgentic, the AI-driven platform revolutionizing automotive retail with intelligent solutions that empower dealership teams rather than replace them. Now let's shift gears and look at how these same technological advances are transforming the customer experience and retail operations.
While manufacturing leads in robotics adoption, dealerships and retail operations are experiencing their own AI revolution. The technology is reshaping customer interactions, sales strategies, and operational efficiency in ways that were barely imaginable just a few years ago.
The automotive AI market, specifically focused on retail and customer experience, has reached approximately $5 billion this year, according to multiple analyst projections. That investment is driving innovations in everything from online car buying to predictive maintenance scheduling.
What's striking about this transformation is how quickly it's happened. 3 years ago, only about 15% of dealerships were using any form of AI. Today, that figure stands at 45% according to the latest technology adoption survey, with another 3-5% planning implementation within the next 12 months. This represents one of the fastest technology adoption curves in retail automotive history.
Personalized customer experiences have become the norm rather than the exception. Advanced AI systems now analyze customer behavior, purchase history, and market trends to create highly targeted interactions that dramatically improve conversion rates.
The impact is substantial. According to Impel's latest industry analysis, AI-enabled dealerships achieve 27% higher showroom appointment set rates and drive a 26% lead-to-sale conversion rate compared to traditional dealerships. Those performance improvements translate directly to bottom-line results.
What's particularly impressive is how these systems are creating hyper-personalized customer engagement. AI systems analyze first-party data like browsing history and service records, along with zero-party data that customers provide directly about their preferences. This creates real-time individualized experiences that feel remarkably tailored to each customer.
One particularly effective application is dynamic website content that adapts to show vehicle recommendations based on detected income levels, family size, or geographic needs. A customer visiting from a rural area might see more trucks and SUVs, while an urban visitor might be presented with compact cars and EVs with good range. These subtle adjustments make the shopping experience feel more relevant from the first click.
AI-driven chatbots have evolved significantly too. The latest generation handles 24/7 inquiries while qualifying leads through sophisticated natural language processing. These systems understand context, remember previous interactions, and can answer complex questions about specific vehicle features or financing options. Early adopters report conversion rate increases of up to 35% compared to traditional lead capture methods.
Perhaps most impressive are the behavioral prediction models that identify life events like job promotions or growing families from customer interactions, triggering timely promotions for larger vehicles or luxury upgrades. By understanding these transition points, dealers can reach customers at exactly the right moment with the right vehicle suggestion.
We're seeing these benefits materialize across various dealership operations. Ravin AI and UVI have pioneered AI-powered vehicle inspection systems that have reduced diagnostic times by up to 40% while improving repair accuracy. Ravin's CTO recently noted that automated diagnostics cut inspection errors by 60%, directly increasing customer trust in pre-owned vehicles.
That trust factor is crucial in today's market. Online retailers like Carvana and Vroom have leveraged AI to streamline sales, trade-ins, and financing, cutting transaction times by 30% and boosting customer satisfaction scores by 22% compared to traditional processes.
One particularly interesting development is how dealerships are using AI to bridge the gap between online research and in-store experiences. According to the latest industry data, 68% of buyers now begin purchases via virtual showrooms, but complete them in person for test drives. AI systems help create a seamless transition between these channels, ensuring that information gathered online is immediately available to sales associates when the customer arrives at the dealership.
Generational shifts are influencing these technologies as well. Research shows that 31% of millennials and 21% of Gen Z buyers use AI-powered configurators to personalize vehicles pre-purchase. These interactive tools allow customers to visualize different options, color combinations, and features, creating a more engaging shopping experience.
Subscription models are gaining traction too. BMW's Access by BMW and Ford's Ford Blue Cruise exemplify software-defined services, with over-the-air updates adding features post-purchase. These models transform the relationship between manufacturers and customers, creating ongoing value rather than a one-time transaction.
The metrics are impressive across the board. A compelling case study from March 2025 showed a dealership using integrated AI tools achieving 1,046 buyer engagements in just one reporting period, along with 952 revived old leads through automated re-engagement. This consistent performance demonstrates AI's ability to maintain sales velocity even in challenging market conditions.
Dealers are clearly recognizing these benefits and voting with their wallets. A comprehensive industry survey released last quarter found that 37% of dealers using AI reported revenue increases of 20 to 30%, while another 26% saw growth of 1 to 10%. The same study found that 81% of dealerships plan to increase their AI budgets this year compared to last.
What's particularly interesting is that 72% of dealers view AI as a job enhancement tool rather than a replacement technology. Staff can focus on high-value tasks like building relationships and handling complex negotiations, while AI systems manage routine operations and data processing.
This collaborative approach extends to customer interactions as well. Dealership staff now use AI co-pilot systems that provide real-time guidance during customer conversations. Sales associates receive instant access to personalized buyer profiles during test drives, while service advisors get AI-generated scripts addressing individual warranty concerns, improving first contact resolution by 40%.
We're seeing the same pattern of augmentation rather than replacement in inventory management, where predictive analytics are transforming how dealers maintain their stock. AI systems now analyze historical sales data, market trends, demographic shifts, and even weather patterns to optimize stocking decisions. This has become particularly valuable given ongoing supply chain volatility and rapidly evolving consumer preferences.
CloudTalk's industry analysis found that dealerships adopting AI inventory management systems have reduced overstock costs by 18%, while maintaining higher availability of in-demand models. These systems can forecast demand patterns weeks or months in advance, giving dealers a significant competitive advantage.
Perhaps most impressive is how AI is enabling proactive sales approaches. By analyzing customer data and behavior patterns, sophisticated systems can now identify potential buyers before they actively enter the market. Impel's analysis notes that dealerships using these predictive tools are reaching customers an average of 45 days earlier in their purchase journey.
Purchase intent scoring uses digital footprints like website clicks and social media engagement to prioritize high-value leads. Meanwhile, personalized email campaigns generate vehicle and financing recommendations using credit history and past transaction data, reducing opt-out rates by 22% compared to generic blasts.
The contrast with traditional approaches is stark. Manual lead scoring has been replaced by real-time predictive analytics, tracking over 120 behavioral signals. Generic service reminders have given way to maintenance alerts tailored to driving patterns and vehicle telemetry. The result is a much more relevant and engaging customer experience.
Michael Rodriguez, general manager of AutoNation's Dallas operations, recently shared, "Our AI system identified a customer whose lease was ending in 3 months, but who had been browsing SUVs online rather than sedans like their current vehicle. We reached out with personalized SUV options that matched their browsing behavior, securing the sale before they'd even visited a competitor. That type of insight was impossible before AI."
The benefits extend beyond the initial sale through post-sale retention strategies. Predictive maintenance alerts using vehicle telematics data have reduced breakdowns by 29%, while loyalty reward programs automatically apply discounts for accessories matching customers' verified interests.
These technologies are helping dealerships achieve 16% higher customer retention rates compared to non-AI adopters, while reducing marketing costs by optimizing outreach timing and channel selection. Early implementers report 30% faster sales cycles through hyper-relevant data-driven engagements.
These changes in retail operations mirror the transformation we're seeing in manufacturing, both driven by the same underlying technological advances in AI and data analytics. Looking ahead, the automotive AI market shows no signs of slowing, with projections reaching $48.59 billion by 2034, growing at a remarkable CAGR of 29.61%, according to Precedence Research.
With all this technological advancement, a question naturally arises. What about the human element? Will these technologies ultimately replace workers, or will they create new opportunities?
Well, the evidence points toward a more nuanced picture than simple replacement. While routine and physically demanding tasks are increasingly automated, new roles are emerging in programming, maintenance, data analysis, and human-machine collaboration. The challenge lies in helping workers transition to these new roles through effective training and education.
Deloitte's 2025 Skills Gap study found that 63% of automotive manufacturers are investing in training programs to help employees work effectively with advanced robotics and AI systems. Rather than eliminating workers, the industry is increasingly focused on upskilling them for higher value roles.
This transformation is creating entirely new job categories. Roles like AI application specialist, human-robot collaboration engineer, and production simulation analyst didn't exist a decade ago. Today, they're among the fastest-growing positions in automotive manufacturing, with average salaries 15 to 25% higher than traditional production roles.
We're also seeing interesting collaborations between educational institutions and manufacturers. BMW's partnership with Clemson University's International Center for Automotive Research has created specialized training programs in AI and robotics applications specific to automotive manufacturing. Similar initiatives are emerging at Michigan State University, Georgia Tech, and other institutions in automotive manufacturing regions.
This collaborative approach extends to dealerships as well. As Jennifer Martinez, Director of Operations at AutoNation, observed during her presentation at the Nedeljković convention in February, AI hasn't reduced our headcount, it's made our team more effective. Our sales staff now spend 40% more time directly engaging with customers rather than managing paperwork or searching for inventory information.
That sentiment is echoed across the industry. Sarah Williams, Chief Digital Officer at Lithia Motors, recently noted, "The most successful AI implementations we've seen are those that enhance human capabilities rather than trying to replace them. Our systems handle data processing, pattern recognition, and routine communications, allowing our team members to focus on building relationships, solving complex problems, and delivering exceptional service."
The future of the automotive industry clearly involves a symbiotic relationship between AI, robotics, and human expertise. From the factory floor to the dealership showroom, these technologies are creating more efficient, personalized, and profitable operations across the entire value chain.
At AutoAgentic, we understand this balance between technology and human expertise. As a human-centered AI company in the automotive space, we're dedicated to enhancing dealership team performance, not replacing people. Our intelligent solutions are designed to empower your staff to achieve more while maintaining that crucial human touch that builds lasting customer relationships.
That's right. Autoagentic is LLM agnostic and deeply trained in the auto industry. We offer a suite of intelligent agents for everything from lead nurturing and inventory optimization to service appointment management.
If you'd like to learn more about how Autoagentic can help your dealership navigate this AI evolution while keeping humans at the center, visit us at www.autoagentic.ai.
Thanks for joining us on this Tuesday morning edition of Auto Intelligence. If you enjoyed today's show, please like, comment, and subscribe wherever you get your podcasts.
This has been Auto Intelligence, produced by the team at Autoagentic. Join us Thursday for more insights that will keep you informed about developments in the ever-evolving automotive industry.